matter what math you're in, you're going to wind up encountering roots. And it is a subject that students tend to dislike. So let's just clear that right up. We're going to do a problem that involves simplifying roots, combining like terms, canceling top to bottom, and then rationalizing your denominator. Let's do it. So there's the problem that we're going to be working with today. The first thing you have to do when you're dealing with square roots is you need to break down what's inside the square root. And let's remind you that the reason you're doing that is because what square root means is what times itself equals something. So for example, if we're looking at something simpler, like the square root of 16, we're saying what times itself equals 16. So we know that 16 could break down into 4 times 4. And so then the answer to what times itself equals 16 is 4 times itself equals 16. And then the sort of hack way to think about that is that when you have 2 of a given factor inside the square root, that's the same thing as 1 of that factor outside the square root. And that leaves us with just a 1 inside, which square root of 1 is just 1 that disappears. So now let's go ahead and break down the gianter numbers in the problem that I've given you. Okay, so I'm going to start with 108. So the square root of 108. All right, so first I see simply there's a 2 in there, so I might turn that into this. And then I see 54, and I know that that's 9 times 6, so I might turn that into this. And then I see that 9 is 3 times 3, and 6 is 2 times 3, so ultimately I'm going to turn that into this. And so now I've broken 108 down into its prime factors, as small as it can go. And so recalling our example of 16, if I see 2 of a factor under the square root, that's the same as 1 of that factor outside the square root. So that means, I've just rewritten it down here where I have more room. I see 2 3s, that comes out as a 3 on the outside. I see 2 2s, that comes out as a 2 on the outside. And whatever comes to the outside is being combined by multiplication. And then I have this lone 3 that has no partner, and therefore it has to stay inside the square root. So 108, square root of it simplifies to 6 times the square root of 3. All right, I'm going to do that again with 432. That's a bigger number, so I'm going to go ahead and do a prime factor tree to start. And again, I see a 2 in there, so I'm going to go for that. And I see another 2 in there. Oh, hey, 108. Well, I already kind of know how that goes, but let's just go ahead and finish it out. And now I'm going to circle all my primes so I can see them all. Okay, so if I'm going to build my square root of 432 and start pulling things out. Okay, so I've put my 4 2s and my 3 3s under this square root sign, and now I can start simplifying. So 2 on the inside yields 1 on the outside. Here we go. 2 2s, 2 2s, 2 3s, and I've got a lone 3 left inside. And so that means that the square root of 432, well, I have a 2 times 2 times 3 on the outside. That's 4 times 3, that's 12. And I have a 3 left on the inside. So that is 12 root 3. Okay, let's finish it up for 60. Okay, well, I know that 60 breaks into 4 and 15. And then I know that my 4 breaks further down into 2 and 2, and my 15 breaks further down into, all right, so there's my root 60. All right, let's pop this stuff under a square root sign and start to simplify. All right, you tell me. That's right, 2 on the inside, 1 on the outside. Here we go. And that's as far as I can go there, because neither the 3 nor the 5 have a partner. So this one simplifies into 2 root 15. Okay, so that's our initial simplification. So now let's go back to our problem and let's put these 3 in for these 3. All right, so that's now so our problem can now be written more simply as 6 root 3s plus 12 root 3s over 2 root 15. I like to employ a little something called CalMath to help you remember what you can and can't do. Root 3 and root 3, those are the same and we're adding them. So 6 root 3 plus 12 root 3 is the same as 6 cows plus 12 cows, which would of course be 18 cows, or in this case, 18 root 3. All right, so now what do I do with that root 15 on the bottom? Well, here's where you want to remember one of your properties that says that if you have the square root of two things times each other, that is the same thing as the square root of one thing times the square root of the other thing. So in this case, that would look like this. Square root of 15 is the square root of 3 times 5, which is the square root of 3 times the square root of 5. And now, since we have a bunch of stuff multiplied together, divided by a bunch more stuff multiplied together, we can cancel, right? You can't cancel when you've got things added to each other, but you can cancel when you've got things multiplied to each other. So I have a root 3 and a root 3 common to the top and the bottom. I may cancel those. And then I have an 18 and a 2, and that 18 contains a 2, right? That's 2 times 9. So I may cancel there as well. All right, so now when I rewrite everything that's left on the top over everything that's left on the bottom, that looks like this. 9 over the square root of 5. And you say, whoo, I'm done, right? Wrong. Okay, your teacher's going to mark you wrong because you may not leave a square root on the bottom of a fraction. It's just one of the rules. Can't do it. So how do you get rid of the square root on the bottom? Well, you ask yourself, what would I need to multiply square root of 5 by to get rid of that square root? You would want to multiply it by itself. And whatever you do to the bottom of the fraction, you have to do to the top of the fraction. So this step, by the way, is called to rationalize. So we're going to rationalize the bottom of the fraction by multiplying top and bottom by that simplified bottom of the fraction. So that looks like this. Okay. And again, the reason this works, root 5 over root 5, that's 1. A cow over a cow is 1. Anything over itself is 1. Okay, so when I do this multiplication, I get the following. 9 times the square root of 5 over the square root of 5 times 5. And remember, 2 inside is 1 outside. That's why we did this. And now our square root has gone away because what's left in here is 1, and square root of 1 is just 1. So our final answer to this problem is 9 times the square root of 5 divided by 5. Congratulations, you have now learned how to simplify square roots, how to combine like terms, how to cancel top and bottom, and finally, how to rationalize that denominator. All right, take a look at some of these other videos that continue to work with square roots, or stretch yourself into using the quadratic formula, which involves roots. Take a look at my videos on factoring. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.